Hello, my name is Nathan Van Velsen, and I'm a lead engineer in the Research and Development Group at Advanced Cooling Technologies. Today I would like to talk about our Navy SBIR Phase 2 program, Developing Thermal Management Solutions for MIDS Communication Terminals. Advanced Cooling Technologies, or ACT, is a premier thermal solutions provider headquartered in Lancaster, Pennsylvania, and catering to the defense, aerospace, and industrial markets. ACT was founded in 2003 in order to pursue SBIR-funded research programs and has experienced significant success in technology commercialization and company growth. Our core values of innovation, teamwork, and customer care enable us to provide effective solutions to our customers' most challenging thermal problems. In this Navy SBIR program, we are developing thermal management solutions for the Multifunctional Information Distribution System Joint Tactical Radio Systems, or MIDS jitters. The rapidly increasing capabilities of the MIDS terminals results in an increase in the amount of waste heat that must be dissipated. Improving heat dissipation to reduce component temperatures can further improve capabilities by improving terminal performance and reliability. In this SBIR program, the objective was to target a 30% reduction in overall thermal resistance between the heat-generating components and ultimate heat sink. In Phase 1, a detailed thermal analysis and trade study of the MIDS terminal was performed, and 2 areas were identified for providing the most cost-effective improvement in thermal resistance and heat rejection. These areas were enhancing the conduction within the electronics cards of the individual SRUs and improving the thermal resistance of card locks used to hold the SRUs in place. Here, we highlight the 3 primary thermal solutions investigated in this program for enhancing the thermal performance of the MIDS terminal: high K and pulsating heat pipe conduction cards, and ACT's ice lock card locks. High K plates, or high conduction plates, are essentially aluminum plates into which heat pipes have been embedded. For essentially the same strength and mass as the base material, ACT's high K plates have significantly enhanced effective thermal conductivity. Pulsating heat pipes, also known as oscillating heat pipes, can similarly be embedded into the conduction cards for enhancing the effective thermal conductivity of the base material. PHPs are an emerging 2-phase heat transfer technology that have similar benefits to heat pipes and can provide effective heat spreading in certain applications. The final technology is ACT's ice lock card locks. The ice lock's novel design has wedges that expand in multiple directions to provide increased contact area for heat transfer. As a drop-in replacement for COTS card locks, the ice lock can reduce the thermal resistance at the card chassis interface by up to 30%. For each of the 3 thermal technologies featured in this SBIR program, the advantages and benefits are similar. High K or PHP embedded conduction cards can be drop-in replacements for the existing conduction cards, with significantly reduced thermal resistance without compromising mass or structural integrity. Ice lock card locks are similarly a drop-in replacement that provides reduced thermal resistance. Reduction in thermal resistance results in lower electronics component temperatures. This, in turn, leads to improved reliability and increased mean time between failures. Alternatively, components can be operated at increased powers for the same component temperatures, increasing the capabilities of the MIDS terminal. Through Phase 2 and Phase 2 option development and close collaboration with the MIDS prime contractors, ACT has successfully qualified and commercialized the high K conduction card for one of the MIDS SRUs, with the first successful hardware delivery occurring in March 2022. Design and analysis of additional thermal improvements, such as high K or PHP versions of the remaining conduction cards, was performed in parallel and has continued after the successful commercialization of the first high K card. As mentioned, one high K conduction card has been successfully transitioned into the MIDS jitters platform. ACT is interested in working with the defense primes in inserting additional thermal technologies into MIDS terminal, including additional high K or PHP conduction cards, continued evaluation of ACT's ice lock, or developing thermal solutions for operation in unique and challenging environments, such as those found on high-altitude balloons. More generally, ACT's high-K, PHP, and ice-lock technologies are widely applicable to any electronics or embedded computing thermal management application, both terrestrially and in space. ACT's goal is to engage with the Navy prime contractors to understand their thermal management challenges and work with them to develop effective thermal solutions that improve the warfighter's capabilities. The three technologies highlighted here are only a portion of ACT's thermal product portfolio. ACT has the capabilities and know-how to solve your most challenging thermal problems, from component to system level. Come see why ACT are the thermal management experts.